Hi everyone. Today, our team is going to talk about an AWS service Amazon SageMaker and how to define, train, deploy machine learning and deep learning models using the service. The data size contains over 300,000 records, each containing information about signed-in users of a company's website, whether they converted or not, as well as some of their characteristics such as their country, age, whether they are repeat users, the marketing channel, and the number of pages visited during that session, as a proxy for site's activity or time spent on site. The object of our example is to develop a model for the e-commerce company that predicts user conversion rate based on the all user information and to give company some insights about how to increase the conversion rate.
Let's go to the SageMaker console. We could take a look at the SageMaker dashboard. There are 5 parts here. You could use the 5 services all together, or you could just upload your pre-trained model, host it, and deploy it. I'm gonna use an example of a built-in Amazon SageMaker algorithm, XGBoost, to show you how to train such a model in a notebook instance using AWS S3. First, we have to create a notebook instance here. I'm gonna name it my notebook instance. To enable the notebook instance to access and securely upload data to Amazon S3, an IAM role must be specified. You could create a new IAM role. Here I will use the IAM role I created before. Note that now the notebook status is pending. Just wait until the status to turn into in service. I will use an instance I created before to save time. Let's open the Jupyter book here, and here we go, the Jupyter home. In the instance, I uploaded the data needed for the model and the code. Let's dive into the notebook instance I created for the model. To prepare the data, train the machine learning model, and deploy it, we will need to import some libraries and set the environment variables for our model. And then we need to use a bucket and to store our data. So let's create a bucket first. I'm gonna make it my name bucket. And click it. Here I use the bucket I create just now. You could create a new bucket or an existing bucket in S3. The next step is to train and deploy the model. The next step is to train and deploy the model. We do some data manipulation, like getting rid of the outliers, and turn some of our input variables into categorical variables. And here is the final dataset we got. Next, we do the training and test data split. We split the dataset into two parts, and the training part is made up of 70% of the whole dataset. Then we transform the data into a CSV file called train.csv, and we got rid of the first row, which is the header, and also we moved the first column as the target variable. Then we load the CSV file to our S3 bucket we built before. The next step, we set up a session for the SageMaker to create the XGBoost estimator and set hyperparameters for our model. Next, we fit and deploy the model and then set an endpoint. Finally, we are able to generate predictions and evaluate the model. The model achieved an accuracy of 98%. And we could also plot the ROC curve and calculate the area under the curve, which equals 2.99, which is really high. So our model achieves very high performance.
For Combator provides some recommendations. We extract the feature importance. The feature importance will extract it from the trained model and will use to identify the most important features in predicting user conversion. These results are shown in graph below. It indicated the age and the number of pages visited were overwhelmingly the more significant predictor of user conversion. Other significant predictors include whether or not a user was new and whether or not they were from China. Although this effect was to a much lesser extent than the number of pages visited and age. A final observation is that the user source seemed to have a little effect on predicting user conversion. In the end, don't forget to terminate the session and delete all the objects in your bucket. As a result, our recommendation is that users who have visited many pages but have not converted likely have high purchase intent. These users are probably the easiest group to convert. Marketing could send them target emails with offers or reminders to encourage buying behavior. At the same time, because using for different countries, pay attention to whether this translated performance of the current version and whether it fits the local culture or not. So that's the XGBoost model that we developed using AWS Amazon SageMaker service. For this particular instance, we helped an e-commerce company to predict user conversion rate and identify important features in user conversion. These insights could provide foundation for recommendation as to how best the company can increase its conversion rate. The notebook instance could also be applied to other machine learning and deep learning models using your own dataset. Thanks for watching. I'm Ruxin, and thanks to my team member Zhongyi Sheng, Zuobei Zhou, Yixi Chen, Seth and Yuan Fang.